Hey y'all, thanks for coming along on this adventure to go through a deployment demo, maybe like DevOps tutorial, not really sure what I'm going to call it. We'll see. If you follow along with me until the end, though, you will learn some great tools, have a really cool demo project to go along with it all. In terms of the why am I setting out to create yet another tutorial course? Um, when I was looking to get into the wide world of development, just bright-eyed, bushy-tailed, didn't know what a terminal was, I stumbled upon El Dorado, infinite intro courses. Most of these teach you things like React, Python, Node.js, maybe some other language. El Dorado has a wealth of knowledge, golden 101 level React courses through boot camps, tutorials, you name it. And from there, a lot of people keep going deeper into the jungle on the yellow brick road. For me, my next step was React Native. And you know what? I loved it. But I was also just doing that because it was an easy next step. It was a logical next step. I didn't know what the other options were. So I am here to tell you that there are other things out there that you can also learn. You can diversify. You can do DevOps, infrastructure, things like Docker, Kubernetes, Terraform. When I was starting to learn these things, I had trouble finding what I would call a bridge course. I knew a little bit, lacked real world skills though, that would just give me enough context to like understand what was really happening. The tutorials were highly specific, pretty advanced. So I've set out to be your guide through the new jungle and to at least point you in the right direction, maybe give you what I would say is a map with a few landmarks to look out for, so you're not starting with a blank piece of paper. All right, so what will we come out of this with? What's in it for me? I promised you a cool demo app. What does that actually mean? So I am assuming you are coming into this with a single page app. My example is a React single page app, but this can be pretty easily customized for other things because it's just an Nginx web server we're using. It's nothing overly React specific. From there, we're going to do some cool things to the app. We're going to Dockerize it, Kuberneterize. That's not a word. Don't actually repeat that. People will look at you weird. We'll use Helm to get it out to the cluster. We're going to learn how to provision a cluster with infrastructure as code using Terraform. And to tie it all together, we're going to automate the process with CI/CD. So we'll update the cluster every time there's a change in the app. What this is and what this isn't. This is not going to be a huge deep dive into all of the bells and whistles, all of the technologies. Really, it's focused on exactly what we need to get this out the door. I know for me, I watched a lot of tutorials that were really deep, and a lot of times I wanted something to just be more broad and simple, just to get exposure to new things, and I'll figure out the rest later. So I'm taking an MVP type of approach. If you hate it, let me know. That's fine. I won't get my feelings hurt. If you like it, let me know too. I do want to note that you can also go through the docs on your own to learn more about anything outside of the happy path here. I just don't want to weigh it down with a lot of fluff. I just want to get you in, get you out, app that covers the basics. Boom, let's go. Moving along. Housekeeping items for when we get to the installation processes. Before we get too deep into setup, I just want to cover some things that used to trip me up when I'd install tools and work through tutorials. So I'm going to get a little vulnerable open here. Path and then modifying permissions of files. I knew this stuff worked, but I had no idea what was happening, why it was working. I was just straight up too embarrassed to ask anybody. So hopefully this helps somebody, anyone. If you're already all good there, feel free to just skip this part. All right, let's talk about path. A lot of times you're going to see path, capital P-A-T-H thrown around. At the command line for context, we have two options when calling a tool or file. So think about some of the Docker and Kubernetes things that we're going to install to be able to interact with those technologies. You can call a command if you are in the working directory where it was installed, or you can call the absolute path where it was installed. Feels pretty unlikely, and it sure isn't scalable to make sure these are always in the working directory. So assuming that we're not going to deal with that part, the main option is to call these where you are. And the command line looks in a predefined location for them. The list of all of these predefined locations are stored in a capital PATH path variable. So when we install something, many times with the instructions, you'll see that you should add it to path. That's what it means. Just getting it ready to be called from the command line. So I'm going to run through a couple commands here. So if you want to get in, play around, look at what's currently in path, here are some commands that'll get you started. They will be in the README also, so don't worry about jotting it down here. You can echo at the path. The second one will actually separate them line by line. And this is where a lot of the pieces are going to be also. So feel free to just get in there, toss in an ls, see what's in there. Sometimes you'll see chmod, chmod, install instructions. What this is doing is just changing, modifying the permissions of a file so you can execute it. Not like French Revolution execution, just run it. Each file and directory in Linux can hold 3 types of permissions: read, write, and execute. Each permission may be on or off for each of the 3 categories of users. So 3 permissions, 3 categories. The categories of users are file or directory owner, other people in the same group as the owner, and all others. The majority of time, it'll be chmod plus X or chmod u plus X. So what these mean, like chmod u plus X file name will grant the execution permissions to the owner of the file and no one else. Chmod plus X file name is the same as chmod a plus X file name. Just give everyone the rights to run the file. If you're doing this on your own and on your personal computer, which you probably are, the user stuff probably won't do that much for you just yet. So just know that's what's going on. All right, so as we start this journey, here's our first stop. Before we get to Kubernetes, I just want to make sure we have the Docker groundwork laid out. We're going to make sure we have the right tools installed, make sure we have a couple of the terms, but not get too deep. I know there are a lot of Docker tutorials out there, and it's typically next step after onboarding with coding languages. We still will Dockerize the app with a multi-stage Docker build, get it set up with an Nginx web server ready to be deployed, but we'll keep the focus there. I just want to make sure, again, we're in and out with the core of what you need. So the things we'll want to have are Docker Community Edition and then Docker Desktop. Here's the local version of the app that we're going to get out there. Really crazy intense app. No, just kidding. It's just a single page app. It's a welcome page for my dogs whenever they get famous and they start dealing with traffic when they get their big break. I just want to have something prepared, ready to go. Going out to Docker, you can see Docker Desktop. I'm going to download this. And give it a few minutes. Watching, waiting, waiting. All right, let's go on. Let's get this installed. All right, now that Docker Desktop is installed, we're going to go to docker.com, make sure we're all set up, username, password, repository. So if you don't have an account, I assume you do, but this would be a good time to do that. Sign in. Great. Docker Hub, I'm going to create a repository. Deployment demo. Created. Public. So y'all can see it. That sure is cool they do this. I mean, talking about user experience. Right there, that's how you push it push it real good. Just a nice touch, Docker. And Docker engine is starting. All right. That was a lot. That took, I mean, for y'all, it'll be really quick. I'll probably skip a bunch of that, but that was super boring waiting for that. I absolutely hated waiting, but I have repository here. Boom, Docker command. I have Docker engine starting. I am ready to roll. So now that we have those, let's quickly hit the relevant definitions and quickly with an asterisk, I guess, relative to how long it took to set up Docker, anything will be quick. But so what is a Docker container? A container is the runtime environment you need to run your app. Application, dependencies, config files, all put together in a neat little package. You can think of a Docker container as a meal prep service to send you all the ingredients to go along with the recipe in a single box. No printing out a list, going to the store, not being sure which type of onion to get. Are white and yellow onions the same? I do not know to this day. It's right there in the package. You are ready to get cooking. Then what's a Dockerfile? Let's keep this one short and sweet. Dockerfile has the instructions for taking a starting image, so a base image, transforming it in some way, and saving the result as a new image. And the new image is the app that we need. Dockerfile is the recipe to follow. What is a multi-stage build? Multi-stage builds let you reduce the final size of your final image. Too many finals. Let you reduce the size of your final image. That makes more sense. And what does that mean? Why do I care? You're going to see multiple from statements in the Docker file, and each instruction uses a different base and starts from a new stage of the build. And you can copy artifacts you need from one to the other, leaving all of the rest that you don't need behind. So when deploying a React app, I don't need everything. I actually just need the build folder that I get when I run npm run build. It's an absolute waste of space to keep everything else. If I have 4 cloves of garlic and I only need 2 tablespoons of chopped garlic, I only want to take the 2 tablespoons over to the next stage. The rest can go to some other little side quest recipe or on a pizza for tomorrow. Sprinkle that on. Really good hack. We don't waste food in this household, but you want to specify what needs to go from the stage you're at to the final result. I think that's probably the last of the food analogies, but no promises. I'm kind of hungry. So how does this all fit into what we are doing? Kubernetes is a useful tool for container orchestration. You define the resources you need, the amount of scale you want, and how to accomplish that. And then simply put, for a container orchestration tool, you also need containers. So we're going to containerize the app and have something to send out to the cluster. All right, time to get cooking. Probably last food thing now. Building the Dockerfile. So let's pull up the IDE. We'll run this live. I'm really just going to copy and paste it with a bunch of the notes. Honestly, I don't like to do it line by line. I don't have it memorized. I still take my notes and do it, and I'll try to comment a lot of the relevant things to help. So when you look back at it, it'll be easy to get up and running. So for my Dockerfile, you can call the Dockerfile anything you want, but the standard is just Dockerfile. Kind of boring, leaves literally nothing to the imagination, but let's not reinvent the wheel here. So let's create a Dockerfile. Dockerfile, and there we go. In here. And I'm actually just going to copy and paste, and then we will talk through it again, not leaving anything to the imagination. All right, so starting at the top, again, we're specifying the base image, and we're calling this stage just build. That'll come back later. Setting the working directory that we're going to be using. This is the build context, just where we are working out of relative to where we are. I'm calling mine app. Just doing standard stuff from the root of this repo, nothing crazy at all. Just keep it really simple. And then we start off with the layers least likely to change to utilize caching. One would hope that your packages would change a little bit less than your app. And then next we just run the npm install, so the command for the packages. You can add -- silent if you want, if you don't want to see it clogging up your terminal. I love the noise, like fired up. And then we copy the rest of the app in there. Now that the full app is over and we want it to be production ready, I'm going to run npm build. This comes with create React app. It just creates a production ready build directory in the app. And that's what I need to send over to Nginx. And then we are off to the next stage. So this is the next from statement, as I mentioned. Going to kick off with the Nginx Alpine image. And then we're going to copy everything over that we need from that build stage. My build directory is under the app and then build folder here. Moving it over to there in Nginx, the TLDR, that's where you want your app to be when working with Nginx. If you want to get deeper, love the docs fired up, all on you. I note the port to expose will be on port 80, and then I just run the command. I need to start it up, and we're golden. So let's run this locally and then see it in action too. Actually, let's pull this terminal up here. All right, so Docker build, tag it, deployment demo latest in the build directory, build this thing. This is going to take a while. Cool. Sweet. It's actually great. We're done. Now let's run this thing and make sure it's all working well. So now that it's built here, I'm going to go Docker run, specify the port 80, as I mentioned, IT demo. If I could type latest, let's run this. Gosh dang it, dadgummit. There it is, ready to roll. Give it the chef's kiss. Now we can send this to the Docker repository. We are going to set some nvars to do this. Have this. Let me actually pop this back over. Actually, you know what? Let's pop back. All right, let's send this back to the Docker repo. Let's shut this down. All right, so you can do Docker login, or you can set your nvars. So Docker repository, Docker username, and Docker password, and then we'll run a couple scripts to do that. So let's run. All right, so to push this up, you need to have 3 nvars set, or 4 nvars set, Docker username, Docker password, under Docker-_user, Docker_password. I'll show you what those look like. Then Docker repository, and that's going to be your Docker user dash the name of the repository. So demo, and then tag. So latest, boom. So you know, log in. How we would do that. This way it doesn't actually come up in the terminal. Pass it in the standard in. Login user. Cache money of me. Let Docker know that this password's coming in hot as standard in. Oh, I called the wrong thing. All right, so let's rebuild this. Do this, in fact. Build it again. Unbelievable. Oops. God, I'm an idiot, but I'm getting it done live. All right, now this thing's built and ready to go up. So now let's push her up. Docker app ready to go. Let's go. All right, on to the next. I can deploy that Docker container somewhere, but the big question is, what if something breaks? There's too much load. Who knows what else? Kubernetes pretty simply is a container orchestration tool. So lets you define the ideal state. So how many containers, how to handle scaling, how containers should talk to each other. And then it makes sure everything is healthy and your ideal state is maintained and can scale up and down. Tools that we will need for this piece. To start, we're going to be using Docker Desktop to test this out. It has some Kubernetes functionality to run Kubernetes and clusters locally. Go ahead and enable that. It's really cool. And then we're also going to want kubectl, so we'll do that after, but we're going to enable this for sure first. All right, so I got a blank screen up here. Let's get Kubernetes enabled for Docker Desktop. Little Docker icon up here, ready to roll. Go to Preferences, and there's going to be a Kubernetes option. To my other screen, pretty classic. Enable Kubernetes, apply and restart. While we're waiting for that, let's go ahead and install the other tool that we need, kubectl. Share this thing. Kubectl is just the way that we interact with your Kubernetes cluster from the command line. It is pronounced a few ways and they are all right. I've personally made the decision, it's very personal, that when I speak about the tool itself, I say kubectl. And when I'm talking about running a command, I pronounce it kubectl. I have no idea why, but I made that decision and my mind truly cannot be changed. Let's go ahead and get to installing. So we have installation here. Here's that chmod finally showing its face, making it executable, and what? Moving it in the path, doing it all. Fantastic. All right. Excellent. We're good to go. Now let's see if the other things are installed. All right. And we see Kubernetes is running. But before we get into it, let's define the terms that we'll be using throughout this piece. A couple in particular will be important when we're dealing with multiple Kubernetes clusters, maybe not now, but something I would recommend being familiar with, context and namespaces. So a context is a combination of a cluster, you being the user, and then the namespace. And a namespace is a way to keep all of the resources you're using in your cluster separate. No peeking from one into the other. The names of things in one namespace aren't visible from other namespaces. So if you name your load balancer something really cool and want to use it in another, or if you call things something more simple like demo in one, you can do that in the other two. If you run kubectl get namespaces, you should actually see a couple set up to start. So those are going to be there by default. Next is a Kubernetes deployment. Deployment's job is just to watch, keep tabs on the associated containers, make sure that everything's good. The specified number of them are always running. Kubernetes has a deployment object for all of the programs it has to look after. It ensures that it has the name, number of replicas, all the things that it needs for each. There are some other pieces. Let's not get too deep in the weeds. We just want to get far enough to be dangerous. So Kubernetes deployment. Deployment's job is just to watch and keep tabs on the associated containers and make sure that everything's good. The specified number of them are always running. Kubernetes has a deployment object for all of the programs it looks after. It ensures that it has the name, number of replicas, and all the things that it needs for each. There are some other pieces, but let's not get too deep in the weeds. Just want to get far enough to be dangerous. Again, just showing you a landmark on the map, not trying to map out the exact way to get there. You might have to figure that out on your own. A Kubernetes service defines a set of pods and defines how to access them. A set of pods targeted by a service is usually determined by a selector, just so keep in the back of your mind there. A pod is the smallest thing that you deploy on Kubernetes. It represents one or more containers that are sharing things like storage or network resources. And a deployment will create and destroy pods for you to keep your ideal state. And you can see in Docker Desktop which Kubernetes cluster. We're connected to Docker Desktop here, but helpful if you're managing multiple contexts to maybe to see it in the GUI as well. I'm going to create a directory called Kubernetes. I'm going to create one for templates. This is a little bit overkill, to be honest, but because I only have one. You can kind of define where you want or what you want to call it if you want to mix it up, but I'm going to call this one demoprod.yaml. This is going to be YAML. It should be pretty straightforward, honestly, to get going. I could pretend like I've memorized exactly how to make it on my own without looking through documentation or having a starter kit, but I haven't. So I'm just going to copy and paste this over with the comments. This will be in the repository so you can dig in a bit more. I try to comment everywhere. I'm going to change the name of this from DevOps demo to deployment demo to match the image. And then we'll just run through a couple of those pieces that we talked about. I mentioned deployment. This just keeps tabs on the pods, make sure everything's good to go. API version, just which version of the API you're going to create and use. You'll see two different ones here. This one's for service. This one's for deployments. Don't worry about it. Just roll with it, copy and paste it. Metadata, so just helping you identify the object. I'm calling this deployment demo. And again, this is YAML, so you can see this is a sub stanza of the metadata, and everything kind of goes sub. So they're all tied up to the parent. For the spec, so here's what the deployment is going to create. Spec.replica, two replica pods. And I can type, I think, pods, the selector, how the deployment finds the pods to manage, and it's using match labels and the deployment dash demo to select. So you can see the match labels down here with the metadata labels, same thing. That's what they'll end up using down there. And the specs, what each pod will do. So it's going to be create a container. It's going to be deployment demo latest. That's what we were using. Image pull policy. This is optional. You can also just omit this if you would prefer. But every time a container is launched, the kubelet queries the registry, make sure it's up to date. Ports, you can tell the port to expose. Again, Nginx or port 80, straightforward. And restart policy. This is the default, just what to do if there's an issue or a crash. In the service, so set of pods, how to access them, the version we talked about, metadata, just helping you identify the object. Deployment demo, really straightforward. Again, once you want to start customizing this, you're free to, but we'll just get through the door here. What it will create, a load balancer, just an external load balancer to manage access to the cluster there. Selector we talked about, and then ports exposes port 80 for the load balancer. So when somebody comes in the load balancer, 80 directs them there. The default protocol for services is TCP. Whew, that was actually not as bad as I thought, pretty straightforward. Now we are going to apply it. So first thing I'll do is save this, as that would be an annoying mistake to make. QTL apply. So we're going to apply something to the cluster that we are connected to. So we have the context set up. Again, Docker desktop is the cluster we're using. I'm going to specify where the file is that I want to apply. Kubernetes templates demo prod.yaml. Wow. And then let's see. Get pods, see all the pods, and I want to watch as they change. And it beat me to the punch, unbelievable. But you see I have 2 pods up here, and I had 2 replicas that were spun up in terms of my deployment. And then get services. You can see that is up. So deployment demo service externally. And then let's go actually take a look. So let's run a new window and see if we actually have it on a local host. It should actually be, boom, like unbelievable news. So I'm very excited. We are up Kubernetes. We deployed our app out to Kubernetes. So even if we stopped there, we'd have put an app on a cluster, and dadgummit, that's pretty cool. But we're going to keep going and actually make this available IRL. I'm very excited. The next thing I want to cover is just creating a cluster, how to do this. There are some manual ways to do it. So we're going to actually do all of our work in Linode. So let me create this account, and we'll go over and take a look. I'm in Linode. You can create a free account here. This will cost a bit of money. I can get you, I think, a discount code. So I'll put one that I could find in the comments. But you can see they have some Kubernetes pieces. So if I want to create a cluster, I can absolutely do this in the GUI. I can do it from the CLI if I want to just do it like that. But also, if we're already implementing DevOps infrastructure, we're going to use Terraform to do this. So that way we can define exactly the cluster we want and actually apply it and interact with Linode through Terraform. So it'll actually provision that whole cluster for us to our specifications that are set up. So it's in the config inside of our source code, so you know exactly what is set up. And then when I want to tear it down, you can actually just run Terraform commands to tear that down as well. So there's nothing left over. There's no confusion having to go in the GUI. Do it. You just manage it all inside of the source code. It's so cool. So instead of doing this, creating a cluster manually here, we're going to set it up in source control. Terraform is the tool that we are going to use. See, open source infrastructure as code. So it just means define what you want in source control, run apply, and actually provisions all of that for you to your specifications. And then you can run destroy, tear it all down. So you have to manage that in the GUI, CLI, not being sure of some of the specifications that you set up and customize. Really, it's best practice to define this in your source control if you can. All right, time for the as code piece of the infrastructure as code section. So first off, we're going to download Terraform, which is going to manage our infrastructure. Go to the Terraform downloads, download it. Again, it says classic little path action here, and moving it to the path. You go to the actual install for the learn. It gives you a bit more explicit instructions, so you can actually see where to move it to get to use your local bin. And then verify with the checksum. You know, ultimately, what you want to make sense is that ultimately what you want make sure Terraform is working, get your version, make sure you're up and running. And for the as code, I'm going to create a folder for all of the Terraform work that I would do, similar to what I did for Kubernetes, and I'm going to make another one, cluster. So this is how I'm going to manage infrastructure for LKE, and I'm creating a specific one for LKE cluster, just so if I want to do something else, kind of with this, I can segment them by that. Something important here, there's a guide here deploying a Linode Kubernetes engine cluster using Terraform. That sounds like exactly what we are doing. If you think that, you are 100% right. If you go to this page and follow the instructions, it'll get you there. Like, you'll be able to deploy it. I want to go through a couple of the pieces and customize it a bit, change the resource classes, update some of the versions. But if in doubt and you want to get up and running, go to the docs, follow a guide. You can start tweaking afterwards, similar to what we're doing, but like, just get it done, get it up, and you can figure it out. So we'll go through this. We already have kubectl. We already have those pieces. You can see we create a Terraform directory, LKE cluster. Now we're on the main.tf, and that's where the main pieces, I guess that's why they call it that, of Terraform live. So let's create a main.tf here. And we'll get going. Again, I'm just going to pretty standard copy and paste, and we'll go over some of the pieces. Okay. So at the top, we see providers. In Terraform, a provider manages plugins. So providers are just a logical abstraction of an upstream API, responsible for understanding the API interactions, exposing resources, doing all the legwork. And this is just stuff you could do with the API, but it's just solidifying what it is and making it really clear. You can think of the provider as the services you're going to use. Again, Linode probably knows the Linode API pretty well, so really trusting them. And they have instructions in the different provider and the different things you want to run. So you can follow the instructions and look at the customizations. Down here, resources. Resources, they're the main piece of Terraform. This is broken into blocks. We only have one resource, but it could be multiple resources broken in blocks. They all describe infrastructure objects that we interact with. So think anything from compute to load balancer to DNS. In our case, we're going to set everything up that's necessary for our Kubernetes cluster as a resource. Pretty simple with Linode. Define the resource here, have a name here, which we'll call down here, we'll call down later. And then inside, there are a couple things that are best practices. Again, these are in the docs. You'll see variables are across the board used. We'll go into where those are established after this. And down here is output. You can expose information for other Terraform configurations to use. You can interact with the CLI, use the outputs to print certain values after running Terraform apply. Just each output here is declared in a block, and you can see them with output variables. And then just the things that you need afterwards. Here I have keep config. I don't want to expose that. Actually pretty sensitive. So I have a sensitive equals true option. So that's just the one thing to note there. I'm going to save it. And then the next thing we're going to create is the variables.tf. Again, that's down here. You can see the sensitive.true in this. Defining your input variables. Now, there's a couple tweaks here that I am actually going to make, so I will go through that. All right. Let me reformat this a bit. Over, okay. And a couple of changes that I made that I just want to clarify too. So the other variable, I have a newer version of Kubernetes. You can see you can specify the type here in a default. So this one just has a description. This means that if it's not there, it'll prompt me when I hit Terraform apply, and I'm going to provision the infrastructure to actually input the variable that I want. If I have a default, it'll fall back to that, and you can again set it up by type. Different types, they're all in the docs. You can take a look. This is the one pretty much they gave me to start. I did make these smaller resources, so I think it's a standard 4 and 8. In case you're paying, you don't want to provision a lot of infrastructure you don't need, obviously. So I just set these up to be small, just because we're testing this out for the cluster. Great, so let's save that. All right, so now that we're all set up, we're going to provision our infrastructure. So it's going to be, and this sets up the providers, the plugins that you have set up. Oops, I'm not in the right directory. Great, so you got to be in the directory where your main.tf is, because it's going to look for that. Now let's init it. Right, so you see now that it goes to Linode and starts matching the plugins that I need, so the providers, and it sets it up, and it solidifies the state that I'm in. So I'm not ever losing anything. I know exactly what was going on at the time, and it's actually tied to that state. Great. So you see prompts in here for Terraform plan. Really good practice before you actually apply the infrastructure to run plan and make sure you have everything set up and see what you'll actually be provisioning. I'm going to go ahead and plan it. Great. So I see what I would be applying. I'm going to do Terraform apply, and I'm going to hit yes when it prompts because I do want to perform these actions. And I'm going to go ahead and let my cluster get created. Oh, now we're talking. Now we're cooking with gas. All right, so the infrastructure is provisioned. You can see this is sensitive as we defined it. Now that this is provisioned and we have the infrastructure that we need, we're going to want to run some commands to actually connect to the Kubernetes cluster. So let my CLI know that there's something out there that I want to talk to. As you know, it's probably connected to Docker desktop currently, and I don't need to just only talk to that. So a couple options in terms of ways to connect and to go about it. One, you can actually download the kubeconfig in the UI. So you need your kubeconfig set up. It has all the information on which cluster you want to be working with. You can have a bunch again and switch context depending on what you're working on. And you can get that kubeconfig down here. So go to clusters, I can see the one I have, and you can actually download the kubeconfig information manual in the UI. Now, we're not UI folks, everything's CLI, so that's not what we're going to do. Spoiler alert. You can also get the kubectl in the output, and that's what we will end up doing. So that's why we have that as an output variable, so we can access it there. So let's run back to this and see what they suggest that we do. So this actually won't work. I think it's dated, but we're going to try it. It's going to run Terraform output, and then the output that we had was kubeconfig. That was set up here. And then echo that, and then base64 encode it and make it a LKE cluster config.yaml. Fairly certain it's not going to work though. I have to change it. Yep. All right. That's my kubeconfig, and this should now work. Perfect. Connected to my cluster. Fantastic news. All right. Now that we are connected to the cluster, we need to get the app out there. So a couple ways to go about it, how we're going to do it. We could do the same thing we did because we're just connected to a new cluster. We could run kubectl apply, pick the file, set it out. Off to the races, we'll manually change it every time we're doing that. We don't want to do that. That's not how we roll. So we don't need these templates anymore. No, ma'am. Absolutely not. Let's go figure out a way to DRY, do not repeat yourself. So how we're going to do this, how we're going to version it is using Helm. So Helm is a package manager for Kubernetes. It just makes it easier to manage Kubernetes applications. A Helm chart is all of the files that you need describing your set of resources wrapped up together. So what we had before for the deployment, the prod demo, just templatizing that. And you can pull in an existing Helm chart. There are a lot of examples for how to do that all over the webs. We're not going to do that. We're just going to spin up our own Helm chart. Let's get set up, go to the installing Helm page. We're not going to do it with brew. We don't need that in our lives. Roll this. All right. chmod. Know it. And then run the script. Just give that certain permissions. Oh, sweet. All right, we're all set up. So let's create a template starter, and we'll go through how to use Helm. Clear this. Go back to the directory we want to be in. All right, so let's first create a directory again, first create a directory. Again, everything is code. So our Helm charts are going to live in a directory called Helm charts. We are in here now. So Helm create is the command, and then we're going to call it React app. Maybe this could be applied to more React apps, but you could also name it deployment demo. I don't want to confuse anybody. I'm just going to happen to call this one React app. So I have this created. I'm in Helm charts here. I created React app. That's the one we just created, and it created for me. And then a few things inside of that to call out. Values.yaml. Here's where we're going to specify some of the default values. We will come back to this, but again, this is all just populated. Thank you, Helm, for doing all this work for us. But first, let's look through the templates a bit. So you see templates here. When we package this up, it will combine all of the files in this directory to make our manifest. The ones that we need are deployment and service. So let's actually go ahead and get rid of the rest for now. Ingress, horizontal pod autoscaler, service account. You're all great. I'm sure you have awesome personalities, but it's just, we don't need you right now. Our paths aren't going to cross. Maybe further on down the road on another tutorial, maybe we could work together, but for now, no need. So service account.yaml, ingress.yaml, and I am not in the correct directory, of course. So React app templates. Cool. Oh man, and I gotta run this. My mistake, y'all. Okay, there we go. Okay, so now deployment service. That mirrors what we saw back in Kubernetes, deployment and service. Perfect, wonderful, fantastic. So we have a deployment service. Let's take a look and then think about setting it up somewhere in the Goldilocks zone for us in terms of templatization. Really simple app with simple needs, really honest work. All right, deployment here. And I'm going to pull this up side by side so we can see what we also had before. Delete this terminal. Perfect. We want to have dynamic variables that might change. So think like Docker image, amount of replicas, labels. We're going to keep the auto scaling values in there as well, just in case we start getting a huge amount of load, which we won't, but just in case. But just to illustrate, really just to illustrate, it's an option in there and one of the benefits of Kubernetes. So let's remove some of the pieces, make it match. I actually have it copied and pasted. You're going to have to excuse me. I know it's lame not to do it live, but it's a little easier to make it. You can see it one for one kind of on the side and comparing, and they're going to match. Again, auto scaling, if something's enabled, you can scale up and down. If not, you're just using a couple things that are really, really similar and kind of defined elsewhere. So if's a conditional, obviously values goes to the values file. You can go to the chart name, but really straightforward pieces. The docs are really straightforward, but this is going to get you up and running. Let's go to the service. Pretty standard service pieces too. Copy and paste over. Make it very simple. So the name, just the React app chart, full name, and then great. So next, how do we get to the input pieces that might change? Some complex options, so focusing on a few dynamic pieces here, a lot more in the docs, more than the default, but if you have to ask, you can't afford it. So let's just do what we need, establish some of the syntax. So image and repository. Let's do it. So chart, we see chart with a capital C over here. Let's pop on in. The only thing we're pulling in here is there's a chart.name. You'll see, so not much in the chart, but just want to know that that's where that is coming from. React apps. So on to the values file. This is where a lot of the fun pieces are coming in. I'm actually going to make a couple of changes for the relevant pieces, but you can see a lot of the YAML pieces going on. So kind of image, and you can set those down here. But here, you can see I'm using nvar here and then nvar here. This is going to be with CircleCI, but it can actually be latest as well, depending on what you want to do. So I'm actually going to hard code this to latest for now. Then Docker repository, so you can even do Ryan Pedersen 2 deployment demo latest. Great. And then deployment demo. Great. Let's try it. Let's try it out. So because we're in a different directory in that we established that kubeconfig where we were previously, let's reset the variable. So I have it over here. Export this. Great. And then let's run the kubeconfig get context. Perfect. So we are connected. So now let's Helm install this chart in the cluster and see what happens. Or first off, let's make sure, no pause, but just see if it works. Great. Just confirm there's nothing under the sleeve. Cluster IP, we are all set. Wonderful news. So Helm install React app. So I want to specify React app, the package that I created, and then where it is. So it's React app under this directory right here. And I'm going to do try run first to see, it's a good practice to see what they will actually be. I made a mistake. I am correcting this. Two mistakes. All right, now we're gonna dry run this. This is why you do it. And I should change the perfect. Look at this. You can see exactly what this would look like if I were to deploy it. So cool. God, Helm is awesome. God, Helm is really cool. All right, now let's actually install it on the cluster. So I'm gonna run this last command without dry runs. This one is for real. Whew. All right, let's take a peek. Oh, pod is up. Service up and going. Oh, let's take a look and see. Oh, this is so cool. Let us take a look. Oh, there we have it. We have deployed it onto our cluster. That is incredible. I am amped. All right, perfect. Okay, so that was really cool. We are all systems go. Checked our load balancer, all working, requesting permission for a flyby. I'm going to stop here. If you don't actually want to get out to a cloud provider also or do a CI/CD, no hard feeling, this is absolutely a success. Everything else is really just icing on the cake. I will also note uninstall. That would be how to take it down. Uninstall used to be destroy, but I just want to note that. I'll include that in the notes. Again, permissions of that kubeconfig file are not set correctly. That'd be a chmod opportunity. This is just a demo. We're going to automate that process. This will be taken down before that's all done. So just note that that will be taken care of, but that would not be a good best practice to actually manage it like that. All right, so this last one, I could talk about this forever, but let me do my best to make it as quick as possible. We're going to automate the whole process. So every time there's a change in the app, we run some tests on the app, build the Docker image for the app if those pass, and then upgrade the Helm chart with the most recent version of the Docker image. So no more manual work, just set it, forget it, keep everything as dry as possible. Dryer's Brig, Ned Dryerton not repeating himself, opposite of Groundhog Day. So let's get this set up and integrated. So first thing we'll need to do is actually commit this to GitHub. All right, let's get this to GitHub. I'm on GitHub, new repository, deployment demo, public, so everybody can see it. All right, so I have committed this code. We are locked and loaded. Peep the git ignore. There are a couple things with Terraform that you probably don't want to have in there. But other than that, we are good to go. I'm gonna set this up with CircleCI. So we're gonna first authenticate. Actually, you know what? First, let's go ahead and create the config file. So let's jump in here. So CircleCI, something to note, what's happening under the hood. So every time there's a change in the VCS, it kicks off a webhook, lets CircleCI know that it needs to run whatever you've defined in the config file. I'm going to pull up the CircleCI config file, and you can see it's in a .circleci directory, config.yaml. Everything that we're going to do in the UI is set up here. You can think of the config file itself as the pipeline, so the body of works into CircleCI on a trigger. And then workflows and jobs are the main pieces. A workflow is just orchestrating which job runs in which order. So I want to run some testing validation. If there's a change that happens on my app that actually breaks some of the testing, obviously I don't want to build a Docker image and send it out to Linode. Once that passes, I'll build a Docker image and then I'll automate the deployment over to Linode. And really a job is just defining an environment and then running some steps in that environment. So really basic, you can see testing. I have the executor here. It's a node Docker image, and then I'm just running run test inside of that. And the same thing for the build Docker image and deploy Linode. There's some couple little nuanced differences from what we did manually, but it's all the same and set up here in the config. So now I'm going to set it up in the UI and kick off a commit, and then we'll see how this goes. Now we are up and we should get a pass on the test. Probably when we'll fail on the build Docker and deploy Linode. So we just want to set the right envars after this. So testing pass, that is fantastic. And now we just need to set the pieces to get us to be able to deploy. So environmental variables, add envars. So similar to what we just did when we were doing this locally for the Docker username and password. So let's go Docker password, and I'm going to stop sharing for a minute and then come back when these are all done. So a couple things just to highlight what differs from how we deployed it to how we're going to try it up efficiently and using some of the built-in envars to get going. So we're running the test, the node test, npm run test. We don't want to build the Docker image and deploy it if it's not passing tests. Building the Docker. So we're building the Dockerfile. We probably don't even need this in there. Docker report repository. We're tagging you with the CircleCI, not latest. So that is something good to note. We're still authenticating in the same way. And then we're pushing to the Docker repository in the same way. And once that is updated, we are running some commands with Linode. So we're setting our kube variable this way. So we have a cluster ID. There's an API endpoint that I will include if you want to get your cluster ID. That's the way to go about doing it. And then we're getting the kube config from that. We're setting an LKE variable with that kubevar, and then we're setting it to bash n, and then we're installing kubectl, and then actually setting up kubeconfig. These are CircleCI orbs, so CircleCI's package manager configuration as code, so it just takes a bunch of the best practices and tidies it up very nicely. So for this, really straightforward to install and set the kubeconfig for the data there. So it'd be under kube variable. And we are installing the Helm client, and we are upgrading the current Helm chart, which is called React under Helm charts. The release should not be DevOps demo, so I will change that before you see it. And then we're overriding some of the tags. So CircleCI SHA instead of latest, and image repository actually will be the same, but I want to go ahead and just establish that to be overridden for best practices. And then we're going to run and see the services in the pods. Okay, so everything we just saw built in that config file, we can see here. It's spinning up my environment, checking out my code, setting up the LKE kube config, installing all the tools I need with Helm, and then it's updating the Helm repo. You can see it upgrades my Helm chart down here. Fantastic. And then we saw that I called that release DevOps demo, so we can see at least differentiating. I'm going to change it back after, not a good practice, but I just want to show that we already had one up there from 42 minutes ago. And then this one was 2 seconds ago. So different release, different load balancer, different external IP. And we're going to see, and there we go. We're up, brand new load balancer, automated it. So any change inside of my app will be deployed out into the cluster. From here on out, all of the piping set up, and I can just worry about being a developer again and just like automating the best practices and scaling. Really exciting stuff. Thank you so much for joining me on this journey. Let me know if you have any questions.